Hey coding buds. So basically in today's GFG POTD we have a problem, Bitonic point, and it is a easy level of problem. And the problem statement is given as given an array of integers r that is first strictly increasing and then maybe strictly decreasing. Find the Bitonic point that is the maximum element in the array. Bitonic point is the point before which elements are strictly increasing and after which elements are strictly decreasing. Here note is also given. Note, it is guaranteed that the array contains exactly one Bitonic point. Okay, so basically in the given problem we have an array which is present in like such a manner where the elements are like strictly increasing, okay, or the array of integers are like strictly increasing, and at a certain point it reaches to that point and then after it is strictly decreasing it. So we have to return those strictly point at which from after that the strictly elements are like decreasing here. Okay, so and that is called as Bitonic point. We have to return Bitonic point. In simple terms we can say that Bitonic point is just a maximum element in the array. So we can simply solve this problem by performing the for loop, and we can give the conditional statement like if array of I is like greater than maximum element, then we can simply store our maximum value and we can simply return it. So basically this is the approach for solving the given problem here. So let's say int, here we can say that int Bitonic point here we have to initialize it with 0, and then after it we can simply like for int I is equal to 0, here we have to starting from 0, then I is less than array dot size. Okay, then here we have to do I plus plus, and after that here I have to check the condition like if array of I is like greater than or equal to, that means strictly greater than or equal to, we can say that Bitonic point. Then what we have to do, if it is like greater than that, then we have to store it in, and then we have to store that particular array of I into Bitonic point, which is like our maximum element and which is also called as Bitonic point. And here we have also guaranteed that the array contains at exactly one Bitonic point. So here we have to say that like Bitonic point is equal to, here we can say that array of I, that means here we have to store that maximum element in the array. Okay, then after that whether it will be like strictly decreasing or not, we don't have to care about it. The simple thing about this one is that we have to simply search and get the maximum element inside the array. That's all about in this problem. Nothing is more about in this problem, like because here the example is like given here like 1 2 4 5 7, like till 7 or till 8 it is like strictly increasing. At the position 8 after that it is like we can say it's strictly decreasing. Okay, so you have to return 8 because 8 is the maximum element in the array. Okay, and then after that it is like decreasing. Similarly, if you're talking about the second example, so here 10 20 30 40 50, so here we can say it is like strictly increasing, but here we don't see that there's any like strictly decreasing. So here we have to just simply return our those Bitonic point which is like having maximum element. Okay, so here we actually get it 50. Similarly, we have to perform our same thing for just finding the maximum element inside the array. So here it is like the same thing. Okay, so we have to simply return our Bitonic point. Let's try to compile and run. It's just a simple thing, and this is the same approach for finding the maximum element inside the array. Okay, so here its comparison is completed. Let's try to submit it. So it's submitted. So that's all for today. Thanks for watching.